Hi, my name is Laura and welcome to my lesson. Today we're going to be talking about balancing equations. So obviously normally I'd have a person in here doing the lesson. So what I'm going to do is I'm just going to point out where I kind of ask you to do something or ask a question so that if you're watching this video you can pause it or something like that. So, balancing equations. This topic is fundamental to chemistry, so you'll learn it throughout Key Stage 3 and into GCSE. And essentially what you do in balancing equations is you have to make sure that there's the right amount of each chemical species. So that's each part. As you can see here, there's the different elements and the compounds. So each one we will refer to as a species. So you need to make sure that there's the right amount of species in the equation for the equation to work. So the reason we balance equations is because of something called the law of conservation of mass. So the law of conservation of mass says that in a chemical reaction, the mass of the products must equal the mass of the reactants. So what exactly does this mean? So in practical terms, this means that the mass of the products is the things that are made in the reaction, so the parts after the arrow. The amount of things after the arrow must be equal to the amount of things before the arrow, or the mass of the reactants. So we do this by looking at the number of atoms on each side. So on the left-hand side, so we've got here LHS before the arrow, and the right-hand side RHS after the arrow. So the number of atoms on each side must match. So that's the number of each individual type of element here. So this can be really easy and quick to check. For example, if we look at this equation here, imagine these two 2's are in subscripts, as you can get that on this interactive whiteboard. So you have C plus O2 on the left-hand side, so the reactants, and then after the arrow on the right-hand side, you have CO2 as the products. So you can see on the left there is one carbon and there are two oxygens. On the right there is one carbon and there's two oxygens. So this equation is balanced. So essentially the core of this topic is counting up the amount of each element on each side and making sure they're the same. So as I said, this is clearly a balanced equation because there's the same amount on each side. So what we're going to do is we're going to look at some examples of balancing equations. I'm going to talk through them and you can work through them with me at the same time. But before we get started, I would ask now if you've got any questions, or feel free to pause the video and read through what is on the notes again, or rewind and listen again, just to check that everything's okay before we move on. So moving on from that, we're going to look at our first example here. So this example has, on the left-hand side, you have iron, you have hydrogen, you have sulfur, you have oxygen. And then you have these things again on the right-hand side in the products. So the technique I like to teach people for this is to write a list for each side. So here I'm going to write which element we have and how many we have of it. So first we have iron, and there's no number on any side of the iron. There's no number before or afterwards. So that means we've only got one. And then we just add to this list. Okay, I'll just write another one. So we've got one iron, and then what do we have after that? So we've got hydrogen, and you can see that there's a subscript 2 after the H. That means we've got 2 hydrogen atoms. And we've also got sulfur. So there's no number before or after the sulfur in this compound. This is a bit tricky because it is in the middle of the compound. But there's no big number before the entirety of the compound where this blank line is. And there's no subscript number after the S, which means we just have one for now. And then the last thing we've got here is the oxygen. So you can see that there's no big number before where the gap is, and there's a subscript 4 afterwards. So we've got 4 oxygens here. I'm just going to add this Fe onto the same list. Brilliant. So now we have a list of what we have at the start on the left-hand side. Now we're going to make a list the same for the right-hand side of the product, so we can see what we've got and what needs matching up. So if we start with iron again, you can see now that there's no big number before again because that's what we're going to add in. But you can see that there's a subscript 2 afterwards. So on this side we've got 2 of iron. And then here it's a little bit more complicated because the sulfate ion is in brackets with a 3 afterwards. You can see that there's no big number before because we haven't balanced it yet. There's no number after the S for sulfur, but this whole iron is in brackets with a 3, so that means the 3 on the outside of the brackets applies to everything inside, so therefore you have 3 of sulfur. And then again, inside the brackets you've got oxygen, and there's a 4 after it, so you've got 4 oxygen inside the brackets. but everything inside the brackets multiplies by what's on the outside of the brackets. You have to multiply the 4 on the inside by the 3 on the outside. So therefore you've got 12 oxygens. And then the last thing in the products is you've got this H2, so you've got 2 hydrogens. So now you can see we have a list for each side here. So the differences we have between what we have in the reactants and what we have in the products is there's 1 Fe in the reactants, but there's 2 Fe's in the products. The hydrogens are the same, so you have 2 and 2. The sulfurs, you have 1 and 3, so you're going to have to do something about that. And then the oxygens, you've got 4 and 12. So now that we know what we've got, we have to look at how we're going to change this to make it balanced, because as we said in the explanation, the number of atoms of each element on the left-hand side here must equal the number on the right-hand side. So the goal of this method is these two lists have to read the same by adding and taking away things by putting numbers in these spaces where there's lines. So we're going to give it a go and just see what we can do to work out what's next. So the key with balancing equations is it is trial and error. You can learn the best techniques for how to do the trial and error, but you do have to try things and sometimes change them. So what we're going to do is we're going to look at what would be a sensible first try. So what do we need to make match? We need to make the ions match first. You've got 1 and 2. So an easy first try is to just put a 2 here in front of this ion, because there's nothing else here. It's just the iron atom. It's not a molecule or anything like that. So when you add the 2, you're not changing anything else. So now, as we've done that, I would recommend going back into your list. Just grab the list and changing it to a 2 now. So that one's done. So now these Fe2s are both the same. Right, so what are we going to look at next that doesn't match? So now let's consider sulfur. So you've got 1 sulfur on the left-hand side, and you've got 3 sulfurs on the right-hand side. And something here to note is because this is an ion, so the SO4, this stays the same on both sides, so it's only multiplied by the 3, but this stays together. So we're going to consider the S and the O together in this, because they change together, because they're together on the left-hand side and they're together on the right-hand side. So this is a good technique. Look, when you're looking at the equation, see if there's any group of elements together in an ion, and see if they change or not on each side, because if they don't change, it means you can treat them as one entity. So you can see here that the ion SO4 has been times by 3 in the brackets. So 1 to 3 means you've times the sulfur by 3, and 4 oxygens to 12 oxygens means you've times the oxygen by 3. So you're going to end up needing 3 lots of this ion on the left-hand side as well. So let's see what we can do and add a 3 and see how this changes our list. So now let's give it an update. So before, for hydrogen, you had H2. But now this has changed a bit, hasn't it? Because we've times the entire thing by 3 before. So we need to have a look now. This H2 is multiplied by 3. So 3 times 2 is 6. So now the amount of hydrogens that we have on this side in the reactants is 6. Now let's look at the sulfurs. So you had 1 sulfur before, but now this entire thing has been multiplied by 3. So you've got 1 times 3. And now the last thing is this oxygen. So before you had O4, but now this O4 has been times by 3. So you have 3 times 4. So that will make it 12. So now let's compare our lists again. You have Fe2 and Fe2, so they're the same. You have H6 and H2, so that's not quite the same yet. You have S3 and S3, so they're the same. And O12 and O12, so they're the same. So now the only thing we have left to change is this hydrogen. You have 6 in the reactants and you have 2 in the products. So the easiest thing to do now is whenever you're looking and you need to make one thing balance, see if you can find it on its own. So when I say on its own, I mean without any other elements in the same compound. So here you have H2, so hydrogen is on its own. So all you have to do now is multiply this so that it matches. So you have 2 at the moment, and there's 6 on this side. So what would you multiply 2 by to get 6? Well, obviously we will know that the answer is 3. So if you put a 3 in here, you can now change your list. So this was H2, but now it's H2 times 3, so it's H6. And then as you can see, in these two lists, we now have the same amount for each one. So that is a quick example of how to balance an equation. So the next thing we would do now, if we were in a class, or if you have the time now, you can pause the video, to just work through these examples 2, 3, 4, and 5. following the same method of writing a list and updating it each time you add a number in front, and see if you can get the answers to those. Thank you very much for coming to my lesson. Hope you enjoy.